In this example, we're going to first create Mohr's circle for this state of plane stress, and then we're going to use that to find the principal stresses and then to show them on a properly oriented stress block. Right? Remember, in Mohr's circle, the variety of things that we want to do first, one, just establish our coordinate system, and we let the horizontal axis be the normal stresses, and we'll put tension to the right, compression to the left, clockwise up and counterclockwise down for the shear stresses. Okay? And so then we go and we find two different points and that are at 90 degrees to each other. So let's take this vertical plane, it's called point A, and that's going to have an 8 KSI tension, and it's going to have a clockwise 6 KSI shear stress. Point B will be on then that orthogonal plane. It's got 12 in compression and 6 counterclockwise for its coordinate pair. Right, we're going to plot those two. And with that kind of scale, we're going to be on both sides of our origin, a little bit more so to the left than to the right. So I think we have enough little squares here that we can call one square a unit. And so let's see here. We go 1, 2, 3, 4, 5, 6, 7, 8. There's 8. And it's 8 tension, 6 clockwise. So that would be up. 1, 2, 3, 4, 5, 6. So 6 and 8 for that little piece. And there's your point A. Point B is 12 compression. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And then down 6 for counterclockwise. So this line is not really hitting that very well, but 1, 2, 3, 4, 5, 6 roughly. Now, if we were really scaling the measurements, as in getting a ruler out to do this, we'd have to be a little bit more careful, but we're just setting up the math with the graphical construction, just like we set up equations of equilibrium based upon a free body diagram, which does not have to be done at scale. All right, so point B was 6 down, and it was a total of 12 compression over. And then we'll draw the diametric line between points A and B. I'm going to double check to make sure I didn't make a mistake. 8 over 6 up. And that was up because clockwise, clockwise. Got it. We're fine. All right. A and B also always have to be on the opposite sides of our horizontal axis. Okay. So now what? Well, where the heck is the center at? The total is 20 from here to here. So split that in half. That's 10. So there's a net here, 2 there. And now 10 on that baseline that goes here. And there's your little triangle. A 6, 10 something triangle. I don't know what that is. Let's find out. 36 plus 100 and square root of 136 is 11.66. So there's your radius for Mohr's circle. That means that we're going to kick all the way out here to about right in here or so. And that is going to be 11.66 minus 2, so 9.66 total right there. This one will be 11.66 plus the 2, so 13.66. So right there, 13.66. There's our two principal stresses right off the bat. All right, let's get this circle drawn in here. I don't know if this is the template we want to use, but that looks pretty decent. It's not close. Let's see if this template works a little better. A little too big. And just about right. It's an easier template to work with than that other one for bigger circles. All right, and that pretty much goes where I had kind of scaled it off at. All right, so that means that we can go find out. We already know what the values of the principal stresses are, but now we want to draw them and we need to find out some angles. So this physical angle here is the angle that goes to the first principal plane. It's twice the real physical one, right? Or a circle, so twice the angle. And so it's going to be equal to arctan of opposite over adjacent, which is all the way from here to there. That's a unit of 10. So that's 0.6. And so 30.96 divided by 2, theta P1 equals 15.48 or 5 degrees, right? And we went from point A and swept a radial line in a clockwise fashion to get over here to our sigma 1, right? So that meant we went 15.5 degrees. So here we start, and we went 15.51 degrees. Bam, that's that location, right? And A had the solid to the left, just like the ruler, so that means that's true here too. So the rest of this is going to look a little bit like this. Square template would be kind of nice and make that easier to draw, but that's our oriented stress block. And then here's your sigma 1. It's, again, 9.66. It's in tension. And then the other one is 13.66 in compression. This is all KSI. And again, that orientation is 15.48 degrees or 15.58. To get there, how did I know that that was exactly what was going on? Well, again, there's your sigma 1. To go from 1 over to 2 is sweeping through 180 degrees on Mohrs circle. That's 90 degrees in real life, right? So that's how we go from here to here. Or if you want to go the other way, you'll be going from there to that one. There's no shear stress on those, right? Because the coordinate that we have here is, that is purely sigma 1 comma 0, just like that one is sigma 2 comma 0, right? That's the coordinate pair for that location. There's zero shear stress on the principal planes, and there's your answer for both of those examples.